Thanks, Vignesh. Just such a deep question. So let me try to get that on a couple different layers without getting too technical. So the brain is a chemical electrical system, and those electrical signals are essentially zero one signals, either continue the information or don't. You can think of the neurochemicals as adding color to that zero one signal. It gives you variety, right? Instead of being zero one, black and white, it adds this. Um, uh, uh, the technical word in psychology is valence. It gives you the kind of how good it is or how bad it is. Yeah, so it creates a much richer experience for those creatures, and that's why this electrical chemical system, which is kind of real kludgy in a way, because you can be short on different neurochemicals, you can fatigue the system, but it's a very effective system to adapt. So one of the takeaways from this. That I only discovered by, because I'm a slow person, by, doing 20 years of research, is that for every experience we see, we have a huge variation in the way the brain responds when I measure 50 people in the same experience. So I think I call it the dirty secret of neuroscience is that we are all weird, right? Our brains are behaving in a very different way sometimes than other people's. We don't know it because we're just trying to fit in as social creatures. We don't want to be too weird if we can help it. But it also means that from a human perspective, we're going to expect inconsistency, right? So if I see Swami today, tomorrow, the next day, one of those days he's just going to do something weird that doesn't seem weird to him because his brain's working differently because he's tired or hungry or he ate some weird thing or he had 14 cups of coffee or right. And for him, it's just going to be daily life. I'm like, oh, that was weird. What was going on here? And so again, for us as individuals, it means that we should have not only tolerance but acceptance for that wide variation in behavior, including in ourselves. And again, we're not going to know it. So from our families, for our colleagues, and here's an example that has happened to me and probably most people, which is you're just cranky at work one day. And then the next day you reflect on that and you go, man, I was really kind of a jerk to my assistant or whatever. And then you got to go in and apologize to go, oh, hey, Sue, I'm really sorry. I think I was really cranky yesterday. I'm like, yeah, you were. What was going on? I'm like, my dog died or I was late for work. I'm sorry. You have to apologize. And we understand that, right? That's kind of weird things happen. Now, if I'm cranky, every day for 3 weeks, okay, that's another issue. Then I got some problem I got to deal with. But every once in a while, having that bad behavior, not bad, but unusual behavior, out of character, that's to be expected. So, second example, if I'm shopping at a grocery store and I'm hungry, my brain wants more glucose. That's the fuel for my brain, and so I'm going to buy more sugars and often more fats, which is a store of energy. So, from a sort of standard view in economics, you are irrational if you go to the store and buy donuts. But from a neuroscience perspective, that's exactly what your brain wants. And so, again, if you're, say, trying to lose weight, you don't want to shop when you're hungry because your brain is changing this cost benefit calculation. So, just to put a cap on that, our brains are big cost benefit calculators, but they're imperfect cost benefit calculators. So when we get changes in neurochemicals, that cost benefit calculation is going to change. We're generally not going to be aware of that. We're just going to behave in different ways. And so we should just accept that we're all weird and we expect that weirdness. It makes life interesting. And a lot of that weirdness is driven by these changes in neurochemicals.